My name is B. Santhosh Kumar, Assistant Professor, IARE Engineering College. Today, my topic is Origins of Digital Image Processing, Fundamental Steps in Digital Image Processing. So, first we have to go for Origins of Digital Image Processing. So, before going to the origins, what are the applications? So, the applications of digital image processing, image sharpening and image restoring, medical image, surveillance, law enforcement, artistic effect, machine robot vision, color processing, video processing. So, image sharpening. So, what is the image sharpening? Suppose I have noisy image is there. So, we have to noise image is there. So, we have to convert to the noiseless. So, how we are doing? So, noisy to noiseless means suppose we have to increase the sharpness, increase the brightness. So, noiseless means suppose in the image, suppose black color is dominating or white color is dominating. So, we have to reduce the black color. We have to reduce the white color. So, image sharpening, image brightness, adjustment of image brightness. These are the image sharpening. And after the, suppose my noisy image is the input. Okay. Noiseless is the output. So, final output where we are storing, that is called image restoration. Image restoration. So, suppose input image is a noise image, output is a noiseless image. So, output image I have to store. Where we have to store? That is the image restoration. So, next medical imaging. Next medical imaging means we are using in X-rays example. Okay, in the medical field, X-rays are the best example for image processing. And surveillance. Surveillance means you are using some GPRS or drone cameras like or satellite. Through satellite, we have to surveillance the earth. And law enforcement. Law enforcement means fingerprint. Law enforcement means fingerprint. Suppose for some person fingerprint, thumb impression or fingerprint is 50% is matching. So I have to convert to the 100%. Is it possible? Yes, it is possible with law enforcement. Next, artistic effect means graphics, 3D. Like these are the artistic effects. Next, machine and robot vision. So manufacturing of robots like this. Why? Because we are using some sensors in that one. And color processing. Color processing means suppose I have the image with black and white. I have to convert into the color. Is it possible? Yes, it is possible to convert into the black and white to the color. Otherwise, I have some blue, green, red colors are there. I have to change the colors. Okay, I have to change these colors. I have to go for another colors. Is it possible? Yes, it is possible with color processing. And video processing. We have, why? Because in the video process, set of images we are adding, that is a video. So, in the video processing also we are using image. Next, origins of digital image processing. So, what are the origins? Suppose I am taking, these are the origins, x-axis and y-axis. Okay, in this x-axis and y-axis, we are taking one image. So, this image have 256 rows and 256 columns. Okay, so I am calling as it is a 256 into 256. So, this 256 has horizontal. This 256 has vertical. So, how many pixels are there in horizontal? How many pixels are there in vertical? So, 256 into 256. So, x coordinate I am taking as a horizontal and y taking as a vertical. So, horizontal 256, vertical 256. So, these are the origins. So, sometimes I will take 3 x, y, z. So, where we are taking x, y, z means in the artistic or 3D effects, we are using x, y, z axis also. So, sometimes I will take only x axis. Suppose I don't want any y axis. So, I am taking as a f of x. Suppose for this one I am taking f of x, y. For the 3D, I am taking f of x, y, z. 3 axis. Okay, I am taking as a 3 origins, 3D, 3 diagonal, or I am taking as a, it is a 2 diagonal. I am taking as it is a 1 diagonal. So, How many are there means 1 diagonal, 2 diagonal, 3 diagonal. 1 diagonal means I am considering as f of x. 2 diagonal I am considering as f of x comma y. 3 diagonal means I am taking f of x comma y comma z. So these are the 3 diagonals are there. I am taking one example for this one. So f of x comma y. The image may be defined as a two-dimensional f function f of x comma y, where x and y are spatial coordinates and the amplitude of the pair of coordinates f of x comma y is called the intensity or gray level of the image at that point. And suppose when x comma y are the amplitude values of f are all finite discrete quantities, we are calling as an image, digital image. Okay, so when we are mentioning the pixels 256 into 256, so we have the pixels are there, x comma y coordinates with pixels are there, each one we are calling as a pixel. Okay, so it is as a pixel. So how many pixels are there? 256 into 250 pixels are there. When I am mentioning the pixels in the coordinates, I am calling as it is a digital image. And what are the neighbors? So a pixel p at the coordinates x comma y has 4 horizontal and vertical neighbors whose coordinates are given by x plus 1 comma y, x minus 1 comma y, x comma y plus 1, x comma y minus 1. Suppose it is one image. So it is one pixel. I am taking one pixel. So how many sides are there for this pixel? It is one side, another side, another side, another side. So I am considering that these are the 4 sides are there. Each pixel has the 4 sides. It is 1, 2, 3, 4. So 1, 2, 3, 4. So I am considering as it is a 4 horizontal, that is 4 coordinates. So P has the P equal to 4 coordinates. So x plus 1 comma y, x minus 1 comma y, x comma y plus 1, x comma y minus 1. So the set of pixels called 4 neighbors of P is denoted as N4 of P. So here 4 coordinates are there. That is the reason I am taking N4 of P. So each pixel is a unit distance from x comma y, and the sum of the neighbors of pi lie outside the digital image if x comma y is on border of the image. Suppose a digital image is composed of a finite number of elements, each of which has a particular location and a value. So every image where we are storing, definitely we need some restoration or memory. We need every image we require some memory or restoration for the digital image, and these elements are referred to as picture elements, image elements, pels and pixels. Suppose this image has the how many pixels are there? Suppose I am taking 128 into 128. Example, I am taking 128 into 128. So these pixels I am taking as this is a picture elements. From the picture elements we are converting to the like this 128 into 128 pixels. So picture elements are converting to the pixels, and these are the also called image elements. Okay, so pixel is the term most widely used to denote the elements of a digital image. So ND of P and N8 of P. N8 of P means I am taking as 8 neighbors. I am taking 8 neighbors. That is a N8 of P. D means we have to take anything. Suppose N equal to 4 or N equal to 4, 8 or N4 of P. If I am taking 8 means N8 of P. These points together with the 4 neighbors are called and 8 neighbors of P denoted by N8 of P. So if some of the points in ND of P and N8 of P fall outside the image, if f of x comma y is on the border of the image. So suppose I am taking ND means N4 of P. I am taking it is a 4 adjacency. If I am taking 8 means N8 of P. So 4 adjacency. 2 pixels P and Q with values from V are 4 adjacent if Q is in the set of N4 of P. 8 adjacent. 2 pixels P and Q with the values from 8 adjacent if Q is in the set of N8 of P. If I am taking M adjacency means NM of P or ND of P. So M adjacency means mixed adjacency. Two pixels P and Q with the values from V are M adjacents if Q is on N4 of P, and ND of P means I am taking N4 of P or N8 of P. Okay, depends on N4 means 4 neighbor, 8 means 8 neighbor. Another one, the origins of the different digital image crossing different dimensions of signals. What are the different dimensions? One dimensional, two dimensional, and three dimensional. So what is one dimensional signal? It is one example I am taking. It is one dimensional. Why? Because I am taking only x-axis. Why? Because I have to take what is the time of the wave. So I need only one side. That is, I need only time, no need of anything. So I am taking, if I need a time only. So that is the reason I am taking x-axis only. So in this waveform, what is the duration of the time from this wave to this wave? So it is a time. So time capital T. I am taking one waveform. I no need of any other waveform, but it is looking like a 2D. But the common example of one-dimensional signal is a waveform. It can be mathematically represented as f of x equal to waveform. So what is a waveform here? I am taking 1D, 2D or 3D, whatever may be, where x is an independent variable since it is a one-dimensional signal. So that why there is only one variable x is used. So why I am taking only one used? As per my requirement, I am taking only one. So that is the reason I am taking one dimension, that is f of x. So the pictorial representation of a one-dimensional signal is given by the above figure shows a one-dimensional signal. Even though it is one-dimensional signal, but we are drawing a two-dimensional space. But here I am taking two-dimensional, but I am considering only one-dimensional. As per my requirement, only I am taking one requirement. So one dimension only I am considering. Why? Because it is a time. Suppose I need also frequency. So I am taking as a y-axis, but I no need of this one. So that is the reason I am taking only one dimension. Okay, that is x-axis. And we can say that the space in which we are representing the signal is two-dimensional. That's why it is look like a two-dimensional. It is looking like a 2, and also we are taking the space as a 2D. So that is the reason it is as a two-dimensional. I am taking, suppose y-axis, what is the height? So what is the amplitude? So I am taking some amplitude of this one. Is it possible with this one? Yes, it is possible. Okay, I am considering as a y. But it is looking like a x. But I need only time. I don't want any amplitude like this. So that is the reason we are considering only one dimensional. Next one is a two-dimensional. So if it is one example. The person is there. It is standing. So it is x-axis and y-axis. X-axis I am taking as a width. Y-axis I am taking as a height. So this person, how much? What is the width and what is the height of this person? Okay, the width I am considering as a x-axis, the height I am considering as a y-axis. Okay, it is a two-dimensional. An image has a only height and width. An image does not have depth. Just have a look at this image below. Okay, only two requirements are there. What does that mean? Width and height. Okay, the person width and height will be considered with the two-dimensional signal. As we already seen that the image has a two-dimensional signal, that is, it has two dimensions. It can be mathematically represented as f of x comma y equal to image. So what is the image? So it is an image with a two-dimensional. So where x and y are the two variables, the concept of two-dimension can also be explained in terms of mathematics. So three-dimensional signal. Three-dimensional signal, as its names refers to those signals which has the three dimensions. Another example of a three-dimensional signal is a cube or a volumetric data, or the most common example would be animated or 3D cartoon character. So okay, but in the real time 3D is not possible. When it is possible, when we are going for the artistic work as a graphics. Okay, three-dimensional signal is only possible with a cube or volumetric or any of the animated or 3D cartoon characters. For this purpose only we are taking three dimension, x, y and z. Okay, three dimension, x-axis, y-axis and z-axis. So x, y, z. So the mathematical representation of three-dimensional signal is f of x comma y z equal to animated character. So I am taking as one animated. Another axis of a dimension z is involved in a three dimension that gives the illustration of the depth in a cartoonist of coordinate system. It can be viewed as a x, y, z. Another is a z. So I am considering it is a f of x comma y comma z is equal to image. So what is the image? So what is the image? It is an animated character. And these are the some examples of image processing or digital image processing. So it is the original image. Okay, it is the restoration image. So after the enhancement means what is the problem here? Suppose in this X-ray, so the brightness is very low or the blackish is high. So it is a noisy. So I have to improve the quality of this one. Okay, it is the original one. It is the original image. It is the output image. So what we done? So from this here to here, what we done? So we are improved the quality and remove the noise. Okay. So it is called image enhancement. So when the original picture we are improving the quality and removing the noises, that is called image enhancement. So we done the image enhancement here. Here also it is a noisy image is there. Noise is there. So we have to reduce the noises. Okay. Here some quality is very low quality. Or okay, here high brightness is there. So whitish is very high. So it is converted to the normal image. I am converting to the normal image. So original image is converted to the normal image. Original is converted to the normal image. Original is converted to the normal image. How? Means we are improving the quality and remove the noise. So this process is called image enhancement. And it is the artistic work. Artistic work means we are adding some 3D or graphics, whatever it may be. So these are the artistic work. The artistic effects are used to make images more visually appealing, to add special effects and to make composite images. And another one is a medicine. Take slice from MRI scan of a heart and find boundaries between types of tissue. Image with gray levels representing tissue density. Use a suitable filter to highlight the edges. So it is a heart image. So I want to highlight these things. What are we want to highlight? The tissue density we have to highlight. So what are the tissue densities are there? We want to highlight of this one. Okay, is it possible? Yes, these are possible to highlighting the tissue densities of the heart. How it is possible with digital image processing we done. So it is also called enhancement. It is called image enhancement. It is another example of GIS, Geographical Information System. The digital image processing techniques are used to extensively to manipulate satellite imagery or terrain classifier or meteorology. So these are the geographic information system. Suppose 1, 2, 3, 4, 5, 6 pictures are there, but we are looking like it is from satellite. We took the images, we took the pictures, but it has some noisy or brightness or increasing or decreased or noisy is there. So we have to reduce the noises. So is it possible? Yes, possible. So the digital image processing are usually also in geographical information system. Next, law enforcement. Law enforcement means image processing techniques are used extensively by law enforcement. Suppose here in the above picture, it is the number plate recognition for speed cameras or automated door. So we are recognizing the number plate and fingerprint recognition. Suppose it is the fingerprint is there. So it is the low brightness. So low brightness is converted to the normal in fingerprint. Low brightness is converted to the normal. So it is a low brightness is converted to the normal, or high brightness is converted to the normal. Okay, these are possible. Yes, these are possible. So digital image processing in the using in law enforcement also. And examples of HCA. Try to make human-computer interfaces more natural. Face recognition, gesture recognition. Suppose here in this picture, only I am recognizing the face. I am recognizing the faces with gestures. And here I am recognizing face with hands. Here in this picture, face with hands. Here only face recognition. Okay, with expressions. Okay, so face recognition, gesture recognition. Does anyone remember the user interface from Minority Report? These tasks can be extremely difficult. Okay, these are extremely difficult, but with the help of HCA, with the help of digital image processing, we are performing these all those things. And image processing fields, in the which field we are using image processing. First one is a computer graphics, second one is a in the image processing system, and the third one is a computer vision. So in the computer graphics we are using image processing. So the creation of the images. So these are not original images. We are creating those images are called computer graphics. In the graphic we are creating some images. And image processing means enhancement or the manipulation of the image. So these are all called image enhancements. Law enforcement, GIS, medicine, artistic effect. So these are the all called image enhancements. So in the image enhancement also we are performing. And computer vision. So in the computer vision, analysis of the image content. So what is the image? So some set of images are there. So what is the content of the image? So we have to find out with the computer vision. So in these fields, computer graphics, image processing, and the computer vision. In these fields, we are using image processing is helpful. And it is a very, very important topic. Fundamental steps in digital image processing. So what are the fundamental steps? It is a knowledge base. First one, image enhancement, image restoration, color image processing, wavelets and multimedia, image compression, morphological processing, segmentation, object recognition, representation and description. So total image acquisition I'm taking first one. First one taking image acquisition. Image acquisition. First, image acquisition means we are selecting the image. So, image enhancement. So, what is the problem here? Image acquisition means, suppose, noisy image. So, the noisy image, suppose noisy image I want to convert to the noiseless. Okay. In the image enhancement, I am converting the output is a noiseless. So the noisy image is converted to the noiseless with the help of image enhancement. And after the noiseless image, where it is storing. So image restoration to store the image. Store the image. So what is the input here? Input is a noise image. What is output here? Noiseless image is the output. So this output is storing in the image restoration. Okay, that is clear. Suppose my image enhancement is a black and white image. So I want to convert to the color. Is it possible? Yes, it is possible. So my image acquisition, my requirement is black and white image is converting to the color image. Is it possible? Yes, color image is processing is possible. Next, wavelets and multi resolution processing. I want to increase the resolutions, increasing the pixels. Is it possible? Yes. From the original image, I want to increasing the resolutions or increasing the pixels. Is it possible? Yes, possible. And the image compression. Image compression means, suppose 1 MB image converting to the 100 KB image. So 1 MB image is converting to the 100 KB image. So we are reducing the size or not? Yes, reducing the size. So we are reducing the size or not? Yes, reducing the size with the help of image compression. So here image compression is reducing the image size. So how we are reducing means we are decreasing the pixels. We are decreasing the pixels. And morphological processing. Morphological means some fingerprint. Fingerprint recognition. Fingerprint recognition we are using, and segmentation. So we are the images are converting to the segments, set of segments. So object recognition. Object recognition means to find the original image. To find image. Next, representation and description. So it is the output image. So what is the final image is the representation and description. So here, first one, I'm taking one example. What is the image acquisition? Image acquisition means what is the input image? So the input is the some scene element is there. So this element, what are the pixels are there? How many pixels are there? So I want to find out the pixels. So it is converting to this one. So each it has the pixels are there. So pixels are there. So the original image is converted to the pixels. Okay. So what is that image? So with the help of illumination energy, I'm applying this one to the input. What is our output? So number of pixels. How many are there? Number of pixels I want to find out. Okay, it is the image acquisition. And image enhancement. Image enhancement means it is the noisy. Okay, noise image is there. So I have to increase the brightness. Okay, so the noisy image is converted to the brightness or noiseless image. So noiseless image, or it is a normal image. Okay, so it is a original image, but original image is converted to the noiseless. Okay, it is a recognition. Identifying image. Okay, that is called. Okay, what is the process means? We are processing image enhancement to the input. Okay, the input is this one and output is this one. Okay, so we are applied the image enhancement to the input image. The output is like this. Okay, and next, image restoration. Okay, this picture has a set of pixels are there and the brightness is very high. So we have to convert to the normal image. So brightness is very high. It is converted to the normal image. Okay. So this normal image, it is the output image. So output where we are storing, where it is storing. So okay. So that is called image restoration. So the output image, the input image is also there in the original image, but I have to restore the normal image. Okay. After the image enhancement, what is this image? Okay, this image I have to store in the image restoration. Okay, restoration means output image. Okay, output image is storing in the image restoration. Next, morphological processing. Suppose this fingerprint, low brightness, okay, or noisy. Okay, this is converting to the normal, or this is converting to the normal. Okay, so this is some noisy image is there. I want to convert to the normal image. Okay, so only for fingerprints, we are using this method. That is a morphological processing. With the help of some algorithms, and we are using some software, we are converting to the morphological processing. We are converting to the normal unidentified fingerprint into the identified fingerprints. Okay, these are the morphological processing. And number plates, core number plates, or these are the morphological. Okay, unidentified image is converting the identified. Next, segmentation. Okay, so segmentation means what is the input? Input is a image. This input is an image converting to the segments. Okay, so set of segments. Okay, so this one, what is the one segment? Okay, this one segment, it is one segment. Okay, so these are the segments. Okay, it is, so in the software it is visible for us. Okay, what is the segment here? Okay, is there any item is there? Suppose it is one, it is a one. So these are converting to the one segment, another segment. Okay, so the image is converting to the segments. Okay, for easy recognition. And object recognition. So how we are recognizing object recognition? I'm applying the input as an image. So image of recognition with the help of software or algorithms. With the help of software or algorithms, object recognition. Okay, we are finding out the what is the original image with the help of object recognition, or we are using some software algorithms. We are finding out the object. Next, representation and description. Suppose one pixel, one image is there. It is in the form of pixels are there. So it is one pixel, one pixel, one pixel. So total how many are there? It is a 6 into some 12 pixels are there. So 6 into 12. So each one I am taking as samples. Okay, for easy recognition. Okay. So these are the image recognition. So what are the samples? These are the samples are there. So this image is converting to the samples. Okay. After then, what is the design? Or what is the occupation? Suppose it is going from 0 to 7. Okay. It is one algorithm. It is one algorithm to finding out the representation of the image. Okay. Like this. Next, image compression. So image compression means suppose my input is a 1 MB image, my output is a 100 KB image. So is it possible? As with the help of image compression, we are reducing the image. So how it is possible? With the help of some software. Here using some example MATLAB. In the MATLAB, I'm using I'm installing some software. So what is the software is in the MATLAB? So in the MATLAB, I'm giving one image. I'm uploading one image. Okay. What is the input image? I'm uploading to the MATLAB. What is my requirement? My requirement is image compression. So my image is an image compression. With the help of software, what is output means? The output is a compressed image. So compressed image means how much? 100 KB. Input is a 1 MB, output is a 100 KB. So it is a compressed image. Okay. With the help of MATLAB, example MATLAB, some software we are using to converting from high size to low size. Okay. So we are reducing the pixels also. Here high pixels are there. So reduce pixels. Next, color image processing. So it is one image is there. It is the input image and it is the output image. So what is the difference? Image means here the colors are unidentified colors are there. So I am applying some colors. I am applying some colors. This one. So these are the apply some red color, white. So we are applying some colors to that one. That is the color image processing. Okay. So first one is the image acquisition, image enhancement, image restoration, color image processing, wavelength and multi-resolution, image compression, morphological processing, segmentation, object recognition, representation, and description. So, so in the image acquisition, it is the first step. Step 1. So modalities for getting the image into the computer. The images is captured by a sensor. Example, camera. Okay, it is we are calling as a camera is a sensor and digitized if the output of the camera sensor is not already in digital form using analog to digital conversion. Okay, analog image I am converting to the digital image. Is it possible? Yes, it is possible. So my analog image is a image acquisition. Okay, my image acquisition. So it is converting to the digital image. So input analog image converting to the digital output image. That is a image acquisition. Next, image enhancement. So what is the enhancement technique? The process of manipulating an image so that the result is more suitable than the original for specific applications. The idea behind the enhancement techniques is to bring out details that are hidden or simple to highlight certain features of interest in an image. So it is a low contrast level is there. I want to convert into the high contrast. Okay. Okay. It is a noisy. Is converting to the noiseless. Is it possible? Yes, it is possible with the help of image enhancement. Okay. It is the input and it is the output image. Next, image restoration. Okay, so the noisy or unidentified image is converting to the identified image. Okay, it is a image restoration. Output storing. Where it is storing means output storing is a restoration. Why I am calling restoration? Already input image is stored in one memory. Output is storing in, we are replacing with the input memory. That is the image restoration. So improving the appearance of the image tend to be mathematical or probability models. Enhancement on the other hand is based on the human subjective preferences regarding what constitutes of a good enhancement result. And color image processing. So use the color of the image to extract features of interest in an image. That is the color modeling and processing in a digital domain. Okay, the input is a unidentified. We are not identifying the colors due to some noise or example. So I want to apply the colors this one. Suppose what are the colors I have applied here? Red color, some white color and green color. Here red like this. So I applied some colors to the original image. Why? Because the original is unidentifying or noisy image is there. So I was changed to the color. Okay, that is called color image processing. Next, multi-resolution analysis using wavelets. So what is a multi-resolution? Okay, so multi-resolution means 256 into 256 pixels are there. I want to convert to the 128 into 128 pixels. Okay, so multi-resolution are the foundation of representation images in various degrees of resolution. It is used for image data compression where images are subdivided into smallest regions. Multi-resolution analysis is a different approach of signal processing that gives as well as detailed information at the same time. When the extension of MRA, which resolves signals in the domain that is best suitable for analysis, and it will give the wavelet transform gives more information than Fourier transform. Okay, wavelet transform is giving more information about the Fourier transform and also computationally efficient. And it is a fundamental steps in digital image processing. Okay, so suppose it is the image, that is a error image is there. Okay, it is a information of the image. It is a macro image. It is a starting of the image, starting, stopping. So comparisons of the image. What is the index? So these are one example of the compressions. Okay, compression means MB is converting to the KB like this. Okay, so the technique for reducing the storage required to save an image or bandwidth are required to transmit. So what is the advantage means? Reduce storing capability. Okay, that is a compression. So morphological processing. Okay, it is completely for thumb or finger impression. Tools for extracting image components that are useful in the representation and the description of shape. In this step, there would be a transition from processes that output image to processes that output image attributes. Okay, so it is some noisy fingerprint is there. I want to convert to the noiseless. Okay, so noisy is converting to the noiseless, or this is converting to the this one. Okay, is it possible? Yes, it is possible with the morphological processing in the digital image processing. And image segmentations. The segmentation procedure to partitioning an image into its constituent parts of image. What is the important thing here? The more accurate of the segmentation, the more likely recognition is succeeded. So if the segmentation is very high, then recognition is possible with this one. So that is the reason image segmentation. The segmentation means the brightness. Example I am taking. It is a brightness is very high. It is looking like to identifying image. Okay, unidentifying image is converting to the identifying image. How it is possible means we are dividing as a segments. If the accurate segmentation is high, then recognition of the image is getting easily, or it will be succeed. And representation and description. So how we are representing the image? Make a decision whether the data should be represented as a boundary or as a complete region. It is almost always follows the output of a segmentation stage. So the boundary representations focus on external shape characteristics such as corners and inflections. Region representation focus on internal properties such as texture or skeleton or shapes. So these are the representations of the image. Okay, this image is converted into the some like this. Okay, some sampling like, okay, after going to the matrix form, it is converting to the segments. Okay, it is the image recognition, representation and description. Okay, so the transformation raw data into a form of suitable for subsequent computer processing description deals with the extracting attributes that result on some quantitative information of interest or basic of differentiating one class of object from another. So object recognition. Suppose here on the road it is one object. So what is the object name? Okay, some bus. What is the object name here? Some car. Okay, it is a van. So how we are recognizing? With the help of object recognition, the sensors are capturing what is the object here. Okay, on the road different vehicles are there. So what is how we are recognizing the object? So it is a process that assigns label to an object based on the information provided by its description. Recognition is the process that assigns a label such as vehicle to an object based on the description. Okay, what is the object name? 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 Okay, so we are finding easily with the help of object recognition. So these are the fundamental steps in digital image processing. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.